were posed this question. It's not a question I asked myself, but I'm going to talk about how we might, what the issues are. And I guess he says, yeah, let's change the slide. That's it. I'm not to at the same time. We'll talk a little bit about the themes, first of all, in terms of what's happening in the world at the moment. I mean, currently 51% of the world's population lives in cities. That's going to grow, and I don't want to repeat what's on the slides at the moment, but interestingly enough, 38% of people live in agglomerations of over 1 million people. That's kind of interesting, because the theme is that people are going to continue to live in cities, and I think cities are actually really important in terms of the way that we look at the impact upon climate change. Cities produce 75% of the world's waste and use 75% of the world's energy, so they're kind of a big deal. I think the other proposition that we would make is that of those the actual building stock, the majority of the building stock operates within those cities. So I guess what we've got to do is we've got to kind of focus in upon those urban agglomerations. And I think currently, politically, thematically, the position is that the people kind of have this notion that they want to live in suburbia or even in some kind of rural, conditions. And in a way, it's kind of misleading. So I think what we want to do is we want to focus upon what's happening within cities. See how these slides are doing. Okay. And I think we just need to look at the United States of America to start off with, because they are the biggest producers of carbon on the planet at the moment, and individually, that's corporately and individually. Average US citizen produces 18 metric tons of carbon. In China, they produce 1/3 of that per citizen. There's a lot more citizens in China. And I kind of like this slide because actually what it does is it kind of sums up the American dream: big gas guzzling cars and diners that produce where you eat vast quantities of beef, which in reality cause global warming in themselves. So I think the American notion that they drive around in cars which are gas guzzlers and they eat a lot of beef is inherently a problem. Whereas in West Germany, which are also pork eaters, they consume half the amount of carbon per citizen. But I guess this statistic is kind of slightly misleading, because does it suggest that American cities are any worse than any other cities? And I think that's probably not true, actually. I think the reason why the Americans are producing vastly more carbon per person is that vast amounts of their population is either rural or suburban. So I don't think there's anything inherently wrong with US cities. I'm going to talk a little bit about Ellis Miller, what we've been doing in terms of sustainability. We've had a long-term commitment to sustainability. I kind of like to say that we've had a long-term commitment to common sense. I've never kind of got the idea why you should use a lot of materials in a building, or why you should use a lot of energy putting together a building, just simply for the sake of it. That's something I've always thought, that you should use as little as you possibly can to create as much as you possibly need. So I think that's our position. It's much more of a common sense position rather than a carbon-related position. I've also kind of always wondered why we don't reuse buildings and adapt buildings as well, simply because there's a whole debate in terms of embodied energy. For those here who don't understand the concept of embodied energy, it costs energy to run a building, to maintain a building, to use a building, but it also costs energy in terms of the fabric of the the building. It seems to me that if you can retain that energy and reuse that energy time and time again, that seems to make good sense. In my introduction, thank you very much, we did win a sustainability award, our RBA Sustainability Award, and as architects we are interested in sustainability and technology, and I think not wanting to defend the whole of the architectural profession. As a profession, we are aware of our responsibilities in terms of trying to be as carbon efficient as we possibly can. I think we as a practice do that probably better than most because we take a pragmatic approach and sensible approach to it. And we also have an inherent trust in technology, and I think that's the interesting thing. That I think that our view is that technology will inevitably solve the majority of climate problems, and I think I'll go on and talk about our relationship with hair shirt environmentalists later on in the talk. This is a building we did in 1991, which is a building in the City of London, and it turned out to be quite an interesting building. It won many awards and was very well received. 1991, sustainability wasn't actually top of the agenda, but we thought that it was actually pretty common sense that we introduced this glass skin on the outside of the building, and effectively what that did was it created an environmental buffer. So effectively what we did was we wrapped the building, a concrete frame building up, which had a large degree of thermal mass, exposed thermal mass, inside a glass skin. And the glass skin wasn't used in terms of passive thermal performance, but it was in terms of active thermal performance. It was in terms of a passive measure. It also had a measure that improved its acoustic performance. It was next door to a busy road. Interestingly enough, relatively small building, 30,000 square feet, but it introduced this concept across the world. Interestingly enough, of buildings that have commercial buildings that have an outside skin that modify the environmental performance. And Richard Rogers, Lord Rogers, a famous architect, has used this concept throughout as an exemplar, and has acknowledged it to us as a practice that this is an exemplar building for that particular practice. So it goes to show that a small practice, a very young architect at that stage. I mean, I was in my late 20s, could actually influence the ways that people build worldwide. So I think that's an interesting notion. This is another building that we did in 1994, which is a House of Future World exhibition. I've always had a problem with timber being chopped up and stuck together with glue. I always found that kind of a bit of an odd and untrue way of building things. It's not predicated on any science, but it's just like it seems to be a weird thing to do that trees grow, and if you engineer timber properly, then you what's the point of cutting it up and sticking it back together again? So this probably I don't like glue ham either. It's probably just an aesthetic thing at the end of the day. That's what we do as well. We do, apart from functionality, we also do a degree of beauty. We were approached by a log cabin manufacturer who said to us, "Can we do a system kit build house using solid timber and highly engineered timber?" And going from kind of doing log cabins, we said to him, "Well, look, actually, at the end of the day, mate, building log cabins is actually quite good. You stack lumps of trees on top of each other, but it's not actually particularly efficient use of your timber. Shall we take a look at what you can use in timber, and we can use our expertise in framing and high-tech framing technology and structural design to design a super efficient long-span timber structure that isn't predicated on gluing things together, and perhaps we can use some of the technology that we've used and techniques that we've used in the past to put steel together and other high-tech materials and use it on timber." So we ended up with this rather elegant lightweight timber kit construction. We were also very interested in the notion of lightweight against high mass construction here, and we also got very interested in the idea of
passive solar collection. So for example, this is a building that we use trompe walls, which are effectively south-facing glass, and using those as solar collectors. And we had a system by which we used solar heating or solar power. This is before we had access to commercially available solar heating panels to preheat the hot water for the house, which seemed to work reasonably well. On top of that, we were looking at insulation. This is a hugely insulated building. And it was we did a little study on insulation, and the question we originally asked ourselves in 2004 was, what was the best kind of insulation to use? And my preference was for high-tech insulation. I've always really liked the insulation that they used in spaceships, which is just an incredibly beautiful product, very thin and rather lovely. Anyway, we looked at different types of insulation and different thicknesses and different performances and different levels of embodied energy, and we settled upon using recycled newspaper here, which seemed to work pretty well. But the real conclusion we came to at this stage, 2004, which is a really big deal, was that insulation was good. Just do it. It doesn't matter what the insulation is. Whether it's recycled newspaper or clever stuff that they used in space. The fact of the matter is, just use shed loads of insulation, insulate things really well, and also mix that up with a notion of some kind of heavy mass buildings. We kind of have toyed with the idea of lightweight buildings in terms of light thermal weight building, lightweight buildings in terms of their physical mass, and the notion of heavyweight buildings, which are sort of kind of exposed thermal mass to create good quality environments. And I think we kind of come down on the side that actually high thermal mass buildings, which are highly insulated, tend to work quite well in terms of user comfort. Okay, this is another derivation. After we did the timber building, we did this artist studio for the Rayner Banham family. Peter Rayner Banham was famous architectural historian and theoretician, and this is an artist studio for his wife. And we were very interested in the notion of this mixture of lightweight and heavyweight construction, and we started to talk here about the notion of lightweight, highly insulated steel framing systems, high performance glass, and passive energy performance in terms of solar collection. And again, we're using elements here. You can see in the slide on the left-hand side, you can see kind of some black doors there. Concealed behind those black doors are black water-filled tanks on the south-facing wall, which we were again using in the early days to create some kind of non-commercial solar gain facilities. So the idea is that there's a mixture between passive and active. And I guess one of the things that we wanted to do is we also wanted to create some spaces that are really rather beautiful, because actually at the end of the day you can create rather boring homes and boring houses that nobody wants to be in, which are terribly energy efficient. Moving on a few years, we were approached by the Women's Institute to do a little headquarters building for them. And I know that Ruth Bond has been to speak to at a conference a couple of days ago. Ruth was our client in those days. Ruth was a rather wonderful client and an interesting person. Came from an interesting background. Her husband is a magician, and she's been chopped up more times than most sausages. You didn't know that about the one of the most influential women in Britain. And Ruth came to us and said, John, we've got a building where none of our members can get in. It was a house in the centre of town. It was very difficult to put lifts and things there for in terms of accessibility. So she said, look, one of our members has got an old shed that we think we could convert into our headquarters building, and that's kind of interesting. That's that's an interesting notion, and kind of thinking that the pig shed was going to be an interesting kind of listed building of some description. Actually, it was a pig shed. It was a pretty rubbish building. But we thought, well, look, at the end of the day, this building's got a large degree of embodied energy within it. We looked at the WI's policies in terms of sustainability, and they were pretty rock on. They were in the right kind of place. We said to them, look, actually, this location is pretty good. It's got public transport links and all of those good things, and we think that we can do something with the existing shell of this building. We can make the best use of the embodied energy. We came up with a whole strategy about how we could use this building, which had no value whatsoever, and turn it into something which would be an exemplar. So what did we do? Well, effectively we kept what we possibly could do. We had a mixture in terms of the technologies that we were going to use here. We used high levels of exposed thermal mass. We built brickwork on the inside of the building. We lined the whole thing with brickwork. On the outside of the brickwork, we then highly insulated the space. You can see on these slides here that we also had concrete roofs, we've got concrete planks in, and those are structural, but they're also about the idea of keeping thermal flywheel, as we call it in the practice, very even, so there's even conditions throughout the building. Naturally ventilated, we had rainwater recycling, and if we just go back to the slide here, we had some on-site renewables in terms of PV cells. You can just see the front entrance, which says WI, if you can just about see it on top of that. So we've got PV cells there, and you can see just in the background, we've also got our rainwater recycling system in an existing water tower. So this building kind of was something that we felt was ticking a lot of the boxes in terms of sustainability. We reused a building. We had lots of passive and active systems placed within the building, and the building performed pretty damn well. And more importantly, the ladies love it. That's a great thing. And it's 2004 now, and the ladies still love it. They love going there, and it gives them joy, and they care for it. And it's something that they like the story of the sustainability thing. They understand what it's all about, and in that sense, it's a good building. But it's just a little building somewhere, and the impact of that building we could probably calculate and put some numbers against it. And I guess we can also say it's a kind of an exemplar building. It's one of those things that other people might look at it and decide that they're going to do things a little bit better. So that's kind of where we got to in terms of sustainability. It was interesting. There was conversation about young people and education. We spent another part of our practice work is that we spent 10 years working on Building Schools for the Future programme with the last government. And one of the things was that our role was to try and ensure that good design got into schools, and one of those things was that we had a large degree of sustainable design within those school environments. And that was in terms of common sense, in terms of let's make sure these buildings perform as well as they possibly can, they make great learning environments. But also, they had an obvious sustainability agenda, so that kids could actually see how their school was going to be sustainable, and that meant perhaps having a little bit of eco-bling on the outside. But we felt that the impact in terms of the energy savings were probably quite low, but the issues were that the kids actually understood that buildings could actually start making an positive impact in terms of their environment, and just getting awareness up. Unfortunately, the government decided to cancel that programme and decided to go down to the lowest common denominator, which is a shame. But some of the buildings we did within that school's programme actually had a major impact, and I think we'll see the fruits of that in the generations to come, in those young people who have the benefit of having good environments which are thought through quite carefully. I don't want to dwell on that notion, but I think And one of the things we talk about is, sustainability. Is it an individual or collective endeavour? I mean, all of the buildings that I've showed you are about the results of action by enlightened individuals or groups of people. And they kind of had a positive impact. Those people have kind of wanted to show the way. There are some really rather good slides where previous speakers have alluded to that notion. But I don't think any of them will pretend to be a universal solution to climate change alone. They're kind of the notion that they change the mood. I guess it's a little bit like grand designs changes the mood in terms of people's expectations of what a home can be. Gets wimpies to up their game a bit. I suppose that's their exemplar buildings. But I wouldn't pretend that they're going to change things. We started looking at the notion of individuals and individual approaches, and isolated action can make a positive action. So lots of people doing lots of little things are going to make a big impact. And Eleanor Ostrom, Nobel Prize winner, did a lot of research into this. And we thought this was pretty interesting. We thought, maybe lots of individuals do lots of things. Insulation of their houses, do lots of little things, changing behaviour. Stopping driving their car 3 days a week, walking to work, etc., etc. And that might have some big impacts. And we think, that's kind of an interesting notion. We quite like that idea. We quite like the idea of bottom up behaviour can have a significant change on climate change and the way that we use energy and things like that. We think that's okay. But we also think that the governments really do have a place, and we do think that there is a collective responsibility, and somehow we can't just turn around and say, well, if everybody kind of gets round to it and makes a decision they're going to do something with their grandchildren, and it's all going to be all right. I don't think that's the way forward. I think we kind of need to we need to have a collective action. Now it's interesting. I was teaching at the University of Nottingham in 2004. These chaps, Robert and Brenda Vale, were teaching there at the same time, and they had a very different view towards sustainability to the one I had. Robert had the chair of sustainability at the University of Nottingham at that time. We'd been building interesting, technologically advanced at the time, sustainable buildings. Their version of sustainability was a very different one. They were building themselves an autonomous house near Southall, just outside Nottingham. And the idea was that this house would be completely self-contained, so much so that they had composting loos and the whole thing. Now, I never kind of got the notion that sort of composting your own shit was going to actually make any difference whatsoever. I thought that the idea of having collecting everybody's shit together and then you treat it in an appropriate way seemed to be a much more sensible way of doing things. But anyway, they talked very much about the idea of kind of locking themselves away in a true backwoodsman style. And I would argue that approach, and I argue with them frequently, that approach was socially regressive, because isolating individualistic action will not secure widespread and somewhat radical change. It goes against the whole of humanity that a bunch of individuals just kind of do their own thing, stick a stockade around their home, and it's going to change everything. The history of humanity is that people get together and they operate collectively. That is the way it is. And actually, social trends are showing that people either want to live in cities or have to live in cities. It is the notion that people get together. So I think their approach, although interesting, was kind of bankrupt. And I go back and talk about the urbanisation of the planet and the rise of the megacity. And I think it's kind of pretty interesting. These megacities are popping up around the world. We do not live in a megacity in London. It's not a megacity. It's kind of quite a big city. It's not the same level of large conurbations in Southeast Asia, and it's certainly it's certainly going to be restricted. But I think, the idea of megacities is interesting, and I think one of the things that we need to deal with is the notion of, okay, all of these people have conveniently joined together in these cities. So in a way, we've kind of contained the problem. Now they are tipping out a shed load of carbon, and they are creating a shed load of waste. I mean, it's really quite scary what these cities are doing. But the good thing about it is, well, they're all together. So actually, once you collect the problem together, in the same way as Bazalgette collected all the poo in London and sent it down to Beckton, all the social trends are actually suggesting that people are actually moving together in cities, and actually their senses for carbon production is kind of getting focused. So that's kind of quite an interesting position to take. Quite encouraging. And we're talking about how can we have game changers, and I guess what the Veils were talking about in terms of game changing is not a game changer. It's kind of peripheral, fiddling around the edges of an interesting idea. And I think our interest in technology and in social change is about how we can make cities better. We make cities using less material, and those cities consume far less carbon and far less resource. But actually, underlying all that, people actually live better as well, because at the end of the day, you cannot sell an idea to a generation that they're going to live worse. It simply just doesn't work. People will not have it. You look at what's happening in Greece at the moment, where the political change is important because people are saying you're going to live worse than the previous generation. It just doesn't work. People say, no, we ain't going to do that. We're not going to do that. And that's an interesting proposition. I'll give you an example of a game changer, and that's microcomputers, desktop computers. I guess that the slide on the right-hand side or left-hand side is how people used to work. They used to shorthand typists and typing pools, all typing away. And the slide is on the left-hand side is of Google headquarters. You can't see a greater change in terms of what technology is delivered in the workplace. So that's what I call a game changer. That's what I define by being a game changer. It's a technological fix. It's an idea. It's a thing that people have invented have changed things in the way that people work. And I don't think I can give a particularly better example of that in terms of the place of work. We also kind of believe that recycling old ideas is actually not such a bad thing, because sometimes if you look at the back catalogue of technology and ideas, sometimes you can recycle a pretty good old idea, use new technology and use it in a completely different way. So we've got a rather old and lovely windmill, and we've got some high-tech windmills there. It's the same idea used in a different way, and both have got the same, I suppose. It's about the way that things are working through history. When we were posed with this question about can buildings solve climate change, I kind of thought, well, actually we've done a lot about solving climate change in a traditional way. The CFWI would tick a lot of those boxes, or the Manson Street project or the schools program. But we thought, well, actually they're not game changers. So we started thinking about who has even alluded to the notion of game changing, and we came up with a guy called Richard Buckminster Fuller. And Bucky Fuller's a terrific guy, engineer, futurist, served in the First World War as a foot soldier, had some really interesting ideas. For those who don't know him, he's really worth looking up. But he came up with the quotation, and it's a pretty good one. Amongst many good quotations, Richard Buckminster Fuller came up with the quotation of Spaceship Earth. that was his quote, and I think he saw the Gaia idea a long time before James Lovelock did. But I'm looking at another quote that Bucky said, and there's many of them. Pollution is nothing but the resources we are not harvesting. We allow them to disperse because we've been ignorant of their value, and that's kind of an interesting notion. So I think Bucky's interesting. So we're going to talk a little bit about ideas that Bucky had, and we're going to try and put them into some kind of positive light and something that's interesting in terms of the way that we can think about the notion of a better world through technology and through design. Okay, bit of Bucky. Famous for making domes. He was primarily an engineer. He thought that the idea of domes was pretty interesting for a whole bunch of reasons. The Eden Project in Cornwall is a direct descendant of his ideas, and we know that we can build big domes and we can create fantastic environments. Interestingly enough, he had a thing called the Dymaxion car, which is a car in the illustration there, which is kind of roundly, streamlined car that was designed in 1932, I would suggest. It was a three-wheeled car. It had a V8 engine in it, but in those days that car would still do 32 miles to the gallon and it would do 120 miles an hour. Bucky really understood the idea of aerodynamics. And you can look at that car and you can see how every modern car has in some way drawn upon that. Interestingly enough, VW camper van directly took their inspiration. Post-war VW camper van took their inspiration from the Dymaxion car. So Bucky's pretty interesting in those notions. He got very interested in the idea of aircraft design and actually how aircraft design was effectively about how much something weighed. Just to give you an idea about how inefficient buildings are, my best friend at school's father was an aircraft designer. He designed wings for aircraft, and I was not being a particularly scientific type person. I am essentially a person who's an artist, and I was having problems with my structural design at university, and I went to my friend's dad and said, I don't really understand how the calculus of structures work. And he said, well, I don't see why you worry. He said, buildings have a factor of safety of 9, i.e. the issue that you have to deal with is that buildings can't be seen to bend. You look out of the window of an aircraft, you see the wing going up and down, and you're not disturbed by it at all. So buildings are 9 times less structurally efficient than aircraft. Do you know how much your building weighs? And he was directly quoting from Bucky Fuller. Do you know how much your building weighs? And that's a really interesting notion about do you know how much your building weighs? And most people don't care how much their buildings weigh. And actually, if you don't care how much your building weighs, you don't know how much material's gone into it. How many journeys have been taken by tradesmen? How many journeys have been taken by carting that material to site? How big is the hole in the ground? It's actually fundamental in terms of designing things. So the notion of how much a building weighs is a fundamental and interesting idea. And this is all back to Bucky Fuller. Anyway, Bucky had a number of good ideas, and Bucky had a very big idea. Maybe you've seen this image before, but this is 1962. Bucky said, right, I know how to design long-span structures very, very economically. I can do this. What I'm going to do is I'm going to propose a geodesic dome, which is a 2-mile diameter over Manhattan. And the reason for doing this is I'm going to make a better environment. And my better environment is going to create a microclimate over Manhattan. So So in the wintertime, people don't need to heat their homes so much. In the summertime, they don't need to cool them so much. Isn't that a jolly good idea? Bucky kind of also said, well, we don't really need to deal too much, worry too much about rainwater. We don't need to worry too much about snow. But there's a much bigger message in here, and it comes back to another thing that Bucky was talking about: is how much do your buildings weigh, and the amount of material that go into those buildings. If, for example, you created this microclimate, you simply don't need to have buildings that keep water out. Now, keeping water out of buildings is a real pain in the backside. I mean, I guess all of you have had leaks in roofs and things like that, and you can see the amount of material that go across cities just to keep the water out of the buildings. You also understand there's sewers, drains, and other kind of civil engineering infrastructure underneath those cities. You also have walls that need to keep out water. Now, what Bucky's idea fundamentally means is that those buildings within that dome, suddenly, because they don't need to keep out water, there's a whole bunch of material types they simply don't need to use. You don't need to have roofs that keep out water. You just need to have buildings that are reasonably insulated and buildings that have good acoustic performance. That's kind of just about it. Then insulated light and those good things. So that's kind of quite an interesting concept. The dome itself, can be used in a way now that probably Bucky wouldn't have thought about in those times, which is about it can also control solar gain. You can use that solar gain in terms of printing on using nanotechnology, PV cells on that. So you've actually got an environment that can work really, really well. So it's a very kind of an idea, a kernel of an idea that we thought actually this is a recycled idea, but it's actually it's not a bad idea. How about this in terms of taking it further forward? I guess in terms of using less materials, those materials can be more fragile because effectively they're not exposed to weather, they're not exposed to erosion, they're not exposed to wind loads. And we go back to this notion of my friend's dad, who's an aircraft designer, saying, hang on, the big problem you've got or the problem you don't have in structural design for buildings is they're designed for stiffness. So they're over-designed by 9 times because of wind. But you don't have wind within the dome. So interestingly enough, we can design buildings that, frankly, can be perhaps 9 times less strong. That's a huge amount of material that you're not using just to stop the building wobbling around. So we thought, well, actually, as an interesting idea, this has got some legs. Let's just explore this notion a bit more. Bucky wasn't stupid. Anyway, this is 1968 Expo in Montreal. This is a geodetic dome where he was talking about the idea of putting things within this dome. And it's rather beautiful. We then thought, and my wife sort of said to me, when I was, she's a dancer, she's not an architect, she's an artist. She said, it would be rather horrible being within a dome. You don't actually have any, you wouldn't have any green space, you wouldn't be able to see the outside. We said, well, yeah, but I mean, the reality is that the Victorians, when they were building cities, they introduced green spaces. And we could have green spaces. We don't need to cover the cities with domes completely. We can have spaces that are open, spaces that are closed. This is not an absolute message, and we've just got this image up here of Victoria Park, which is a green lung within the city. So we then started looking at the reality of, is this possible? Is this truly possible? And we know that we can create large scale, long span structures. We know that we can put buildings within buildings. We know that we can actually specify these buildings and build better, cheaper, and more efficiently, and we can create better spaces. We don't need to have sealed off domes, and Bucky was kind of suggesting there was this hermetically sealed dome. those airflows are controlled, so then you can have much more efficient structural design. Then we can talk about scale, and I've got the Miller viaduct here, and I just thought it was an interesting image, because if we can build long span and we can build high, then we can build some pretty big things. If you can build a bridge, you can build a roof. And just to give you an idea of actually what we can do at the moment, the tallest pillar or upright of that viaduct is over 320 metres from the floor of the valley to the deck. To put that into some kind of perspective, you can stick the shard underneath there in totality. So the idea of us not being able to build structures over cities is technically feasible. It's there. That's real. That happens. So our idea is a kind of a notion, and it was just sort of something we leave you with, which is about utopia. And Bucky said something which I thought was interesting. Is utopia or oblivion? And I think what we need to do is we need to make cities absolutely incredibly good places to be. I think people can live differently, and they can live better. I mean, just living differently is kind of is okay. I mean, people do live differently. People are naturally adaptable and will adapt with change. But we need to give them an incentive that change is for good. So we kind of came up with this idea of a utopian city, and okay, just give me a license. I'm an architect. I'm an artist, and that's kind of we have to dream, because actually what we can't do is we can't think about recycling our shit forever. We actually have to think about doing things in a better way, because actually that's the human spirit. That's the reason why we went to the moon. That's the reason why Columbus went to America. Anyway, these little pods here that we've created aren't so little. We thought that it would be quite good that if you had a mixture between parks, open space, and these kind of biomes, that would be pretty good. And within each biome, you could perhaps have a 5-minute walk to your nearest park or nearest open space. And we could connect this all together with a rather elegant grid of sort of roads where you had sort of kind of personal transportation devices. I don't know what they would be. They could be electric cars. They could be moving conveyor belts. They could be train tracks. They could be tramways. They could be all sorts of things. So we create these smaller communities. And each one of these communities, I guess, would probably have about 3,000 people. And we started thinking about this. I mean, this is just an idea. This is just to kind of get people thinking about how it could be better. And there's not a lot of science in these things, because actually what we're trying to do is trying to be a little visionary here and saying this is the city of the future, or the near future, we hope. We thought, well, actually, communities about 3,000 work pretty well. They're pretty good. People can know each other. Those can be broken down into communities of about 150 people, so that people start talking to each other. We have a city here of about 1 million people, and this city of 1 million people is carbon neutral. It's probably possibly actually being beneficial, because what we're doing in this notion is we're using the notions of urbanisation, but that's also protecting the stuff that isn't urban, and it's also not changing people's lifestyles in such a way that it will be deemed to be much worse than it already is.